Hi everybody. Today we're going to be going over a basic model of monopoly and go over a simple example problem. Now, a monopoly is obviously just one seller, which means they have control over the entire market. We can start off by looking at their demand curve. And one interesting thing that you will find is that the demand curve for a monopoly is also its average revenue curve. To find the marginal revenue curve, first what we're going to do is we're going to draw a very simple graph here. And imagine that this is showing price and quantity, and we are going to draw out a demand curve. It's going to be a very simple demand curve, so it's going to be at 6 and 6. So this equation is just P equals 6 minus Q. For the monopolist, this demand curve is actually the average revenue curve. And to explain why, let me just present you with an example. So imagine that the price is 4, right? So if we go here at a price of 4, that goes out here to the demand curve, and that means that the quantity demanded will be 2. Now, that means that for the first item that we sold, we get $4. For the second item sold, we get $4. And so on average, we're getting $4. That's really all that means. So for a monopolist, the demand curve is the average revenue curve. Now, if we want to find the marginal revenue, we can't just get there straight from the average revenue. What we have to do is we have to convert the average into the total. And if you know anything about averages, it's very simple to get from the average to the total, because to get from the total to the average, you just divide by Q. So for example, the average here when we were doing it in our little simple equation was, we add up 4 plus 4, right? That was 8, and then we divided it by Q, which was 2. So 8 divided by 2 is just 4. Another kind of maybe simple way of thinking about this is if we multiply both sides of this average revenue equation by Q, right? So P times Q, and if you think about what P times Q is, that's just total revenue. So P times Q, and then we'll do Q times the other side, which is 6Q minus Q squared. And that is our total revenue. Now, to get to the marginal revenue, all we do is we take the derivative of the total revenue. So marginal revenue, therefore, is equal to 6 minus 2Q. And that means that this curve, the marginal revenue curve, will have twice the slope as the average revenue curve. So I'll kind of draw it right here on the graph. You can see that's our marginal revenue curve. And now we can take a look at an actual problem. So you can see that our cost function is 10 plus 2Q. So if we take the derivative, that would just be 2. So we plug that in. All right, move to the next one. Now you can see that this goes through the same process that we already tried before. So we have the average revenue function, and then we multiply it by Q to get the total revenue. And we get 16Q minus Q squared. If we take the derivative of that, you can see it's just going to be 16 minus 2Q, which we put in there. And then finally, solve for Q. So marginal revenue equals marginal cost. Now, you might try to go too fast and make a mistake like we did here, but take a close look. So 16 and then minus 2Q equals 2. So if we minus 2 from both sides, we'll get 14. And then if we add 2Q, so we get 14 equals 2Q divided by 2, Q equals 7. And then finally here, we just plug that Q, how much we want to produce, back into the demand function to see what price we should charge. So 16 minus 7 is just 9. That's the optimal price, profit maximizing. We are done. Okay, moving on. Now we can actually take a look at a graph here. And you can see that when we're changing our price, our profit is changing. And if we go too high on the demand curve or too low on the demand curve, you can see that profit's not optimum. But there is the optimal point, and where the marginal revenue equals the marginal cost. and we have consumer surplus, and we have deadweight loss as well.